So this is the 8th video on Newton's laws of motion. This is in continuation of the 7th video. So in this also I'll take up problems on integration of Newton's second law. Okay. Newton's second law integration based problems I'll take up. Fine. So first I'll write down the question. Question is this. A particle P of mass m, particle P of mass m is initially at rest. And is subjected to a one-dimensional time-dependent force F. Given as F is equal to F naught sine omega t. Alright. Here F naught and omega are positive constants. Here F naught and omega are positive what? Constants. Question is, find the distance covered by the point in time 0 to t. Find the distance covered by the point P in time 0 to t. Okay. This is therefore the question. Now how do we proceed to solve this question? That is the main. See, we have been asked to find the distance. Now we know very well that when speed is integrated with respect to time, we get distance. So we know that ds by dt is the instantaneous speed, that is just the mod of v. This v means velocity. This means modulus, magnitude of velocity is speed. So ds becomes mod v dt. So integrate on both sides, integrate this equation on both sides. Mod v dt 0 to t, 0 to s. S is equal to mod v dt 0 to t. Okay. Now what is mod v? Mod v is the speed. To know the speed, we must first know the velocity v. How to find the velocity v? Now the force is time dependent force. We apply Newton's second law to point along positive x direction, along the line of its motion. So here we don't write f dash and f double dash, just net force F itself is given. So we write it as m times dv by dt, m times dv by dt. A line of motion, a dot n simply becomes a dv by dt. Is it clear? Okay, clear this also. What do I write down the equation? F is equals to ma. Now we are writing the equation along its line of motion. So this vector sign goes away. So what we get is simply F equal to ma. Now F becomes F naught sine omega t. Straight line motion. A dot n is simply a. This becomes m dv by dt. So this becomes m dv equal to F naught sine omega t dt. Okay. Now I integrate this equation on both sides. 0 to t, when 0 then v is 0. At t velocity becomes v. I integrate this, it becomes mv. F naught comes outside. This on integrating and inserting limits we get cos omega t minus 1. So v becomes F naught by m omega 1 minus cos of omega t. This is the velocity of point at time t. Okay. So this also a rub. Okay, fine. So v is this much. Okay, fine. Now see, this is the velocity at time t. But we are interested in speed. The speed of particle at arbitrary instant is simply mod v. That is modulus of this quantity. Modulus of F naught by m omega 1 minus cos of omega t modulus. Now f naught by omega is a positive quantity, it comes outside the modulus sign. it becomes f naught by m omega modulus of 1 minus cos of omega t. But we know for all real values of t, for all real t, cos omega t is less than equal to 1, which means for all real t, 1 minus cos omega t is more than equal to 0. This means mod of 1 minus cos omega t is nothing but 1 minus cos omega t itself. Is it clear? Fine. So this means mod v is simply this much. This I substitute here. So mod v speed becomes f naught by m omega mod of 1 minus cos omega t, which is simply 1 minus cos of omega t itself. Okay, this mod v. I'll substitute this mod v here to get the distance moved. So this becomes 0 to t f naught by m omega 1 minus cos omega t into dt. Fine, alright. This Arab, this one Arab, okay, fine. So distance s covered becomes how much? F naught by omega constant hai, comes outside the integral. So it becomes f naught by m omega 1 minus cos of omega t dt 0 to t. This becomes f naught by m omega integral dt 0 to t becomes t, and this one integrated and inserting limits, we get omega sine omega t. So this one simplifying becomes f naught by m omega square omega t minus sine of omega t. This is therefore the required answer to this question. Okay. See, whenever you ask to find the distance, you must be cautious. You must, from problem, you must be able to observe whether speed is itself numerically equal to velocity or is it different from it. But in this case, we found that velocity itself was a non-negative quantity. So speed is numerically equal to just the magnitude of velocity itself. Okay. This problem also I have discussed. I'll take up second question on this video. Second question. Second question is this. A particle P of mass m, a particle P of mass m is initially at rest and is subjected to a time dependent one dimensional force F given as F naught cos omega t, where F naught and omega are positive constants. Okay, fine. This is a bit, okay. First thing is this. We have to three parts of this question are there. First part says that after what t start after at what instant after t equal to 0 the point momentarily comes to rest. Point P momentarily comes to rest. That is the first part of the question. Second is what is the distance moved by the point during this above time interval, which has been found in part A. The time interval in part A. and C is what is the maximum speed? What is the maximum speed of this point in the time interval in part A? In the time interval in part A. Okay. So these three things have been asked. Fine. I wrote this much. Okay. So now, first thing is, after what minimum time starting from initial instant that is first come to rest? So what do we do now? How to solve this question? That is the problem. So what we do is that we apply Newton's second law to this point at arbitrary instant. Okay. So net force F on the particle is equals to mass times acceleration along straight line motion. Okay. M times A becomes dv by dt. Okay. F becomes F naught cos omega t. Okay. Now substitute send dt that side. F naught cos omega t into dt. Okay, fine. Now integrate this equation on both sides. 0 to t. Initially v is 0, t time it becomes v. V is the velocity, not the speed. M goes outside. Integral dv 0 to v becomes v. F naught comes outside. 0 to t cos omega t dt. Okay. So this becomes mv is equal to F naught by omega sine omega t on inserting limits. This means v is equal to F naught by m omega. Is the answer, is the v. Now it is asked after what instant after t0 the point momentarily comes to rest. So when p comes to rest, implies v becomes 0. This implies F naught by m omega sine omega t is 0. This implies sine omega t is 0. Now I love this. Okay. Now sine omega t is 0 when? It is 0 when omega t is equal to n pi. Where n belongs to the set of positive integers 0, 1, 2, 3, 4 and so on. So t becomes n pi by a. So after t equals 0, so at what time instant does it come to rest? T belongs to the set 0, sorry, not a, omega. 0, pi by omega, 2 pi by omega, 3 pi by omega and so on. T belonging to 0, pi by omega, 2 pi by omega, 3 pi by omega and so on. Okay, fine. So now first it was at time 0 it was rest. Next when it comes to rest after first time after time 0, that is pi by omega. So first answer becomes pi by omega. This is the answer to part A of the question. Now what was part B? Part B was what is the distance covered by point in this time interval. So now how to find the distance as we did in the last question. We know that ds by dt, that is the speed mod v. V is the velocity. V which you get here, this v is the velocity and this mod v means speed. So ds means mod v dt. This means integral ds is equal to integral over mod v into dt. Now in the time interval 0 to pi by omega, we have to find the distance moved. 0 to s. This becomes, left side becomes s. 0 to pi by omega. Mod v. V is how much? This much. We take its modulus because speed is the magnitude of velocity. Magnitude of f naught by m omega sine omega t dt. Okay. Now f naught by omega is positive. It comes outside the integral. So s becomes f naught by m omega 0 to pi by omega mod sine omega t dt. Fine. Alright. Rub this one. See, now this, in order to integrate this term, modulus sign has to be removed. Now mod of sin omega t is always more than or equal to 0 by definition of modulus function. I have to write this quantity inside this integral in such a way that it becomes positive and modulus sign doesn't appear. Now you see, t lies between, this case, between what limit? 0 to pi by omega. This means omega t lies between pi to 0. Now in 0 to pi we know that sin omega t is lies between 1 to 0. It is a non-negative quantity. So this interval 0 to pi by omega, sin omega t is a non-negative quantity. So this means in this time interval of interest, mod sin omega t is nothing but sin omega t itself. Modulus sign can be removed because it is positive by itself. I rub this one, okay. So we substitute this here. So distance covered becomes f naught by m omega 0 to pi by omega. Mod the sign goes away from this result. Sin omega t dt. Now when you integrate this and insert limits, what do we get? F naught by m omega square minus 1 cos omega t 0 to pi by omega. So this becomes minus f naught by m omega square. Upper limit becomes cos omega into pi by omega minus cos 0. This becomes minus f naught by m omega square. Cos pi becomes minus 1, cos 0 is 1. So this one simplifying becomes 2f naught by m omega square. This is therefore the required answer, okay. This is the answer to part B of the question, okay. And lastly, what was asked? I love this one, fine. Now C part says, what is the maximum speed of point in this time interval? Now in the part A of the question we found V to be f naught by m omega sin omega t. F naught by m omega sin omega t. Now in this t varies from 0, that is the interval of interest. So omega t lies between pi and 0. In this case now we know that sin omega t varies from 0 to pi. So sin omega t will have maximum value when omega t is pi by 2. Omega t pi by 2 lies in this interval. So sin omega t will have a maximum value of how much? Plus 1. When omega t is equal to pi by 2. That is t is equal to pi by 2 omega. So V maximum velocity becomes, we should replace sin omega t by plus 1. So V max becomes how much? F naught by m omega into plus 1, which is simply f naught by m omega, is therefore the required answer. Is it clear? Fine. Alright. So this also I have explained fully. Alright. Is it clear? So this I repeat everything, okay? Now I take up the last problem of this 4th 8th video, okay? Last problem. I write down the equation, I write down the question. A particle P of mass m is initially released from rest. Initially released from rest, so that it begins to descend under gravity. Free fall acceleration g is given, small g, okay, constant. apart from weight of the particle or time dependent resistive force F naught equal to kV acts on it, where k is a positive constant and v is the instantaneous speed of the particle, is the speed of p at time t. Okay, question is find first v as a function of time, velocity v of point as a function of time, first thing. Second, acceleration a as a function of time, and third, you draw the vt graph. Draw the graph of v versus t. Draw the graph of v versus t. These three things we have to find out. Okay, so I solve the problem here. First, what I do, I draw the diagram. Suppose this is the ground level. Particle p is initially somewhere here at time 0. It is at rest. It is released from rest. It begins to descend under gravity. At certain instant t, when the point has come here, it is a speed v in downward direction. At this instant, what we do, we have to find this v as a function of t in first part of the question. At time t, what I do, I draw the free body of this particle as seen from ground frame, inertial frame. Which forces on the real force mg acts, and a resistive force also acts on it. What do you mean by resistive force? A force which opposes its motion. So resistive force will act in upward direction opposite to velocity v, and its magnitude is kv. Okay. Now what I do, I apply Newton's second law to this point in downward direction. So I take this downward direction to be y direction. Okay. So net force on the particle in y direction is equals to m dvy by dt. Now one thing, point is moving in one dimension on y axis. So vy, that is y component of velocity, is nothing but v itself. This v over here. Now fy is the net force on the particle in downward y direction. That we written as fy dash minus fy double dash. That is equals to vy is simply v, as explained just now. Now fy dash is what? It is the y component, sum of y components of all the real forces on particle which make an acute angle with downward y direction. Only that force is mg. It makes 0 degree positive y direction, 0 degree acute angle. So fy dash just becomes mg. What is fy double dash? Fy double dash is the magnitude of sum of magnitudes of y components of all the real forces on point which make obtuse angle with downward y direction. That is only one force kV which makes 180 degree with downward y direction. So fy double dash simply becomes kV. This becomes m dv by dt. Alright, fine. Let's rub this one. Now, this equation I solved, this first order differential equation, you can see it. So I write this equation in this way. dv by dt plus kv by m is equal to g. Now this differential equation is of the form dv by dt plus k1v equal to k2, where k2 is equal to g, a constant, and k1 is just equal to k by m, that is also a constant. From theory of first order differential equation, general solution of this differential equation will be written as k2 by k1 plus c e power minus k1t, where c is some constant to be found from the given condition of the problem. Now instead of k1 we have k by m, and k2 we have g. So this solution is valid for this problem also. So we write v barabar k2 by k1 g upon k by m plus c e power minus kt by m. Alright. So this becomes how much? So v becomes mg by k plus c e power minus kt by m. Now how to find C? See, at time 0 the point was at rest. So time 0 V is 0. At t barabar 0 we are given that V is 0. T0 V0. So 0 is equal to mg by k plus c e power minus 0. E power minus 0 becomes 1. So c becomes minus of mg by k. This c I substitute here. V becomes mg by k minus mg by k e power minus kt by m. This is the V as a function of time. First answer we have obtained. What is the second answer? Second is a AT graph. A is, we know, straight line motion. A is equal to dv by dt, straight line motion. dv by dt, when you derivate this, how much will it become? It becomes this derivative of this quantity becomes 0, constant, and this becomes how much? Minus mg by k minus k by m e power minus kt by m. So this k goes away, m goes away, this minus becomes plus g e power minus kt by m. This is the answer to the second part of the question. Fine, alright. And lastly, we are asked to draw the graph, VT graph. See, VT graph is absolutely, see, I write down the expression for V which I obtained here. V is just equal to mg by k minus mg by k e power minus kt by m. Okay. Now you see, at time 0 V is 0. As t tends to infinity, e power minus kt by m tends to 0. That means V tends to mg by k. This will call as Vt, say capital T. It is called the terminal speed. This is the terminal speed of the particle. So graph of Vt will be something like this. Like this, see. At long time V will tend to what value? Mg by k. Initially V was 0. See, this is the graph. So as t tends to infinity, V almost tends to mg by k. Mg by k is called the terminal speed. See what happens in this problem. I'll just state one thing. See, I wrote down the equation m dv by dt is equal to mg minus kv. Now see, initially v was 0, so it was having mg in downward direction. It moves downward, it gains some speed. As it gains some speed, some resistive force kv begins to act on it. Now as the speed increases, this term goes on increasing, but this is a constant amount. At certain instant, what happens? At certain value of v, this term just matches this, and this term just matches this. Then expression dv by dt becomes 0. Then subsequently velocity stops to increase any further. Velocity becomes constant at what value? When dv by dt is 0. If you write this as 0, then 0 is equal to mg minus kv. So v becomes mg by k. This is the terminal speed of the particle. So in a long time, speed v of particle almost tends to this value. It asymptotically tends to this value. It stops increasing any further. Okay. So this is the required graph of the v of speed v of particle as a function of time. Alright. This was the 8th session on Newton's laws of motion. Okay. So next videos I'll take up some more questions on integration based problems on Newton's second law. Okay. So this I close it here. Fine. Alright.